Spire is really happy to be working with Hancom in space to deploy the first private satellite for a South Korean company. Hancom 1 will have an optical payload hosted alongside other missions on a Spire 6U satellite.
Spire's yields a proven flight heritage and vertically integrated uplink from design to mission operations. Therefore, Spire has been the right partner for Hancom in space for its on-orbit demonstration and for setting a foundation of future scaling.
Spire is excited to be supporting Hancom in space in its mission to become a key provider of satellite images over East Asia. Hancom will be building its constellation on top of Spire's proven satellite, ground, and space operations infrastructure, leveraging our over 350 years of spaceflight heritage, end-to-end manufacturing capabilities, and extensive launch partnership network.
Through space services, what we now let third parties do is deploy their own applications using that proven seamless platform of space, ground, and web to grow and scale more cost effectively and for lower risk. What makes Spire a great constellation operator are two things. Firstly, our satellites are multi-sensor, and secondly, we have been deploying our constellation iteratively. What that means is our own constellation is very heterogeneous. We think of it like a mosaic of different satellites with different capabilities. That means we needed to develop a lot of automation and optimization to operate that system as a cohesive system, which our customers for space services can take advantage of. So rather than thinking of operating a set of individual satellites, they can operate a cohesive system in a way that delivers data that's more valuable for them and their end users. So Spire Space Services has everything you need to take your idea to orbit and then operate it effectively when you get there. So that obviously starts with the mission design services, of which Spire can support. Then when your payload becomes a real thing and you're actually manufacturing it, you can take advantage of the end-to-end manufacturing facility that we actually have right behind me. So you can take circuit boards and pieces of cut metal, integrate them into a satellite, and do all the pre-flight acceptance testing that you need before you get on a rocket. Spire Space Services has all the key elements that you need to run an effective and successful space mission. That includes end-to-end manufacturing facility, which you can use to take basic hardware into something which is fully flight acceptance tested, including anechoic chamber, shake and bake with your TVAC and 5. We have a pre-booked launch manifest, which allows us a lot of flexibility to schedule and reschedule missions as things change. We have a global ground station network of over 30 sites worldwide, which gives you very rapid access to your satellite and low latency. And lastly, we have the satellite platform itself, of which we've launched 140 and accumulated over 350 years of flight heritage since 2015.
So about, I want to say 7 years ago, I was at the Techonomy, and I was asked to change the audience's mind in 30 seconds. And so I walked in there, I walked on the stage, and I said, close your eyes. Now I'm going to say a word, and I want you to picture that word. And I want you to then think about what other associations you have for that word. That word is satellite. What do you see in your mind? How big is it? How expensive is it? Who makes it? Who uses it? Where does it come from? Most of the audience did indeed close their eyes. And I took from behind me a CubeSat that I was holding in my hand. And I asked them, if you didn't picture this, you were thinking last century. Because today a satellite is the size of a bottle of wine. It is the cost of a Tesla. And it is smarter than most satellites ever built. That is what a satellite is today. The same way as the PC revolutionized mainframes. When people picture their computer, it wasn't a room anymore, it was something on their desk. CubeSats and small satellites are revolutionizing what we do in space, redefining what it means to be a satellite and who gets to use it. There are certain problems which you can only solve from space because you need to cover, let's say, the oceans or like remote regions of the Earth, right? And if you want to do this with any meaningful temporal resolution, frequency, how often you visit that, you know you need to have a constellation. I still think that the very best way to understand what is happening right now is studying the analogous transformation, the analogous disruption that happened when in the late 80s and early 90s, mainframe computers were replaced by personal computers. And then eventually those personal computers were connected and you had the internet. That's exactly what is happening today here. When you think about mainframe computers, they were basically only available for government. They were custom made, long lead times, very costly. They didn't have any standard software. That's exactly how traditional large satellites look like. The average satellite program since the 60s and 70s and 80s of large governmental organizations is like $2-3 billion when you average it out over all satellite programs that exist, right? What has happened now is that same shift from non-standard, monolithic, large, mostly government-owned devices to rapid innovation, small devices, commercially driven, used by government and commercial entities that happened in the late 80s and early 90s in the computer world is now happening in space. And there is a similar fundamental force or law or whatever you want to call it that is driving that transformation. We have an improvement of capabilities per kilogram, capabilities of a fixed size satellite of 10x every 5 years, which is a little bit faster actually than Moore's law. And that massive transformation of capabilities, that hyper exponential improvement of what can be done per kilogram of satellite is the true disruption driver. That's the equivalent of Moore's law. That is what the research that I did before starting Spire showed by reading more or less all the papers that had ever been written about CubeSats at the point in time, studying their capabilities in terms of power, pointing, compute, storage, antenna bandwidth, download speed, all of those capabilities. And what I saw was this very, very stable 10x every 5-year capability improvement that is truly driving what is happening here.
As someone that has seen Spire's technology evolution over 10 years, I think one thing to note is that we're a very iterative company. So we start small, we start with a couple of features that we think make sense for our customers, and then we start building features on top of that and capability on top of that. And we found that that's a really good way to get to very excellent capabilities by starting small, getting feedback from your customers, and then improving things. Doing that, we've started from just developing CubeSats with limited capabilities to really having one of the best networks in the world with capabilities that nobody else has. What excites me today about what Spire is doing is just what we can enable for our customers. We've built a lot of infrastructure on the ground and in space, and we're opening up the ability to do new things in space to a lot of people, either by using the data that comes down from our constellation or by enabling custom applications in space. And I think that's really the goal of anybody today that's operating in the space industry, whether it's launching big rockets so that you can get more applications in space, or enabling our customers to do it through software like we're doing, or through custom applications. So whatever that is, we'll see the creativity of our customers developing and deploying these applications that will be able to help people on Earth. As part of our mission to enable more customer applications on our constellation, one of the features we're building is a satellite, which is bigger than what we've built in the past. And it just enables different types of payloads, different types of systems to be flown using our existing satellite subsystems and existing infrastructure in orbit, which enables a whole new range of applications for our customers.